Alrighty, folks. So some people were asking about properties of logs and why they work. So this is going to be a real short screencast on the explanation of them. All right. The first question was, we were talking today about why if I have e to the ln of a, why does that just simplify down to a? And it's not because the e and the ln cancel. It's because of the idea of exponentials and logs are both inverses of each other, and they're just another way of writing each other, right? So to do this, I'm going to start off by rewriting just the idea. If I have e to the ln of a, I'm going to set this equal to some variable called y. Now, even though this has an ln in it, this is an exponential because I have a base of e raised to a power, right? Well, if I rewrote this in log form, wouldn't it say the log base e of y equals the ln of a? Well, log base e is the same thing as ln. I mean, that's just the short way of writing log base e, isn't it? So don't I get the ln of y equals the ln of a? Well, golly, if these two natural logs are equal, and because they're one-to-one functions, I know that if the natural logs are equal, then their arguments must be equal. So y must be a. Well, if that's the case, then this y here must just be a. And that is why e to the ln of a is just a. Okay, now let's look at the product property of logs. The product property of logs says if I have log base b of u times v, that equals log base b of u plus log base b of v, right? Well, let's do this. Let's start with log base b of u. I want to set that equal to the variable x. And I want to take log base b of v, and I want to set that equal to the variable y, right? Well, if I rewrote these two equations in exponential form, wouldn't I get b to the x equals u and b to the y equals v? Well, if I take these two equations and I multiply the left sides times each other, I get b to the x times b to the y must equal u times v, right? But I know that b to the x times b to the y using the property of exponents, isn't that b to the x plus y power equals u times v? Is that correct? Yeah? Well, wait a minute. Now let's rewrite this in log form. If I rewrote this back in log form, when I get log base b of u times v equals x plus y. But wait a minute. Going back to the very beginning, what did we say x equaled? Didn't we say it equaled log base b of u? And didn't we say that y equals log base b of v? So log base b of u times v must equal log base b of u plus log base b of v. And that's how that works. Now, the quotient rule would work the same way. You should try that on your own if you want to try that. Okay, let's go to the next one. Now, based off of that, I'm now going to do the power rule. And the power rule, the way I developed the power rule is going to be very similar to the way you developed the double angle rule for, say, sine or cosine back in trig, right? The power rule says if I have log base b of u to the v power, I can bring that exponent of your argument down and becomes a coefficient of your log, right? Well, to prove this, again, here's what I'm going to do. I want to start off by saying, let's let log base b of u equal x, okay? Well, let's again do log base b of u again equals x. Well, if I rewrote this both in exponential form, wouldn't it b to the x equals u and b to the x equals u? And if I multiply both sides, wouldn't I get b to the x times b to the x equals u squared? So wouldn't I get b to the 2x equals u squared? Well, again, if I rewrote this using exponential log form, wouldn't it become log base? All right, sorry, I had a slight interruption there. Okay, so we were rewriting this exponential in log form, and I would have gotten log base b of u squared equals 2x. Well, wait a minute. Again, didn't we define x to be log base b of u? So wouldn't it say log base b of u squared equals 2 times the log base b of u? Now, I did it for 2, right? And by creating 2 of these logs and calling them both log base b of u equaling x. Does it make sense that I could have done it for 3 logs, 4 logs, 5 logs, and it would have worked the same way? So that's why this rule of if the exponent of your argument is here, you can bring it down and make it a coefficient of your log. Let's try it in another one. Okay, the next one was the change of base formula. And the change of base formula says that if I have log base b of a, that is equal to, and specifically I can write that as the natural log of a over the natural log of b. It doesn't have to be natural log, and as long as the bases of your logs match, it can be anything, right? But I'm going to start off again by doing this. I'm going to call this log base b of a equals y, correct? Well, if I rewrite this in exponential form, when they say b to the y equals a, well, because this is a one-to-one function, I can now take the natural log of both sides. I can say natural log of b to the y equals the natural log of a. Now, using that exponent rule that we just created, can't I move the y to the front and get y times the natural log of b equals the natural log of a? Well, simply by dividing by natural log of b, I get the natural log of a over the natural log of b equaling y. But again, what does y equal? Well, according to this, that y equals the log base b of a, right? So couldn't I plug this up here and get log base b of a equals the natural log of a over the natural log of b? And that's where that comes from. And those are why those formulas work.